Oh hey, didn't see you there. I'm Brian Fantana, and today we will talk about nuclear energy. Today we will discuss the process of how energy is produced using this alternative source. We will look at the benefits and issues with nuclear energy and see how it will benefit in the future. And it works 60% of the time, every time.
The process of creating energy using uranium in nuclear reactors starts with mining uranium ore. Uranium can be mined in either open-pit mines or closed-earth mines. After being mined and stripped down, it is enriched from uranium oxide into uranium hexafluoride. After being enriched, it is formed into uranium fuel pellets and then shipped to the nuclear reactor facilities, where the pellets are put into fuel rods. These rods are put into the fuel assembly, which is the heart of the nuclear reactor. There are two types of reactors. The first is a boiling water reactor, which boils water and turns the water into steam, which is sent to the turbine. The second is a pressurized hot water reactor, which heats water, in turn heats another amount of water, and turns that water into steam, which is sent to a turbine. In both cases, steam is sent to the turbines to create electricity. To heat the water, the nuclear reactors have a reactor core. In the core are fuel assemblies, which have rods which are made up of uranium fuel pellets. The uranium and plutonium fission to create heat. Fission is done by a neutron hitting the target nucleus and splitting the nucleus to create two fission products, and also creating heat. The water flows through the assembly and takes the heated water to make steam, which turns the turbine and produces electricity. The reactor core is controlled by control blades or rods, which can be inserted to stop fission and to control the reaction. The water that is not turned into steam needs to be cooled down, and is done so in a couple of ways. The first is that these nuclear power plants are usually located by a large body of water, which helps cool the water. The second way of cooling the water is by using cooling towers, which people see more often emitting steam. And that concludes the process of creating electricity using nuclear power. In terms of production costs, the cost of nuclear energy is far less expensive than all other alternative sources of energy. In terms of the future of nuclear energy, it will last for a very long time.
Nuclear energy does not have several pros, but for what it does, it is very significant. It does not emit harmful and dangerous gases into the Earth's atmosphere. It gives off less carbon dioxide into the atmosphere than most gases. The nuclear plants where the energy is produced do not produce gases that can hurt the atmosphere. The nuclear waste that is given off can be reused and is helpful to the Earth. The prices are lower compared to other gases used. It has a large power generating capacity for large cities and factories. Nuclear energy is used throughout the world. It is most widely used in the country of France. France is 77.7% nuclear dependent, which is the most in the world. Nuclear energy is best suited for making heat and electricity for large cities and factories. It can be used in medicine, making quick and accurate diagnosis. In the future, nuclear energy is well suited because it provides large amounts of energy, it is less costly than fossil fuels, and waste can be reused. The greatest challenge for nuclear energy is that if it comes within contact of humans, it is extremely dangerous to their bodies. It is a very dangerous resource because it can be used for the wrong reasons, such as weapons of mass destruction.
While nuclear energy is known as one of the most efficient and environmentally friendly forms of energy, there are multiple downfalls to this process. For example, the radioactive waste produced from the fissioning of uranium remains for thousands of years, leaving behind a risky and hazardous disposal process. Safe disposal locations have been established far from society and deep underground for the waste to remain until the hazardous levels of radiation have disappeared. However, these locations have filled up quickly and are not sufficient enough to store the nuclear waste of the entire world. As you most likely have heard, there are times throughout history where nuclear plants have had meltdowns or other malfunctions, causing for widespread radiation. A few, for example, are Chernobyl, Three Mile Island, and Hiroshima. As radiation enters the body, it disrupts living cells. This can cause reproductive mutations and even cause cancer. For example, a study done of 100,000 Hiroshima survivors showed 400 more cancer deaths than normal, proving that the radiation caused some people to develop cancer. A meltdown occurs when there is a loss of coolant water in a fission reactor, causing the rods to overheat and allow the uranium pellets inside to dissolve, exposing fuel. This exposed fuel will eventually melt its way through the contaminant vessels to the ground below, causing a meltdown. The worst meltdown known to man occurred in 1986 in Chernobyl, Ukraine, killing at least 31 people from the immediate result and killing 15,000 more in the area from radiation. This example of a meltdown shows the severity and seriousness a meltdown can create.
Hi, I'm Ron Burgundy.
Hi, I'm Brick, and we hope you enjoyed our presentation on nuclear energy.
After learning about the process of creating energy using uranium and nuclear reactors, we hope you found the pros and cons of this alternative source of energy interesting and can see how it can be used in the future.
I love nuclear energy.
Are you just saying you love things that you see?
I love LAMP.
And that's all of us. Stay classy, San Diego.